Hello everyone, myself Professor Pritish Chitte, working as an assistant professor in Department of Mechanical Engineering in Walchand Institute of Technology, Solapur. In last session, we have discussed some of the processes regarding additive manufacturing. So this is the second session of the additive manufacturing in the course additive manufacturing. So the content will be like introduction to the additive manufacturing and the additive manufacturing process. The students will be able to explain different processes with respect to additive manufacturing. So in the last session, we have discussed what is meant by additive manufacturing. So additive manufacturing is a process with the help of, we can call it as a design. Yes, that we are saving it with the help of .stl, and we are providing to, we can call it as different 3D printers. Yes, the STL file will be converted to .g code by slicing the particular a CAD model. The design will be in the form of a CAD model. The CAD will be converted into a particular, we can call it as a prototype. Yes, but how? Yes, with the help of 3D printer. So there will be the development of a prototype with the help of a design by layer process. Yes, by layer process. That's why the additive manufacturing is also called as layer by layer manufacturing. And as there is a use of a design or the digital data, this process is also called as digital manufacturing, as there is a use of CAD design data or digital data. Now also we have discussed lithography process, or which is also called as vat photopolymerization. In the vat photopolymerization, there is a use of a liquid resin and the UV laser. UV laser, whenever it is touching to the tank or to the liquid resin, there will be the development of the particular one solid layer, that will be the conversion of liquid into one solid layer with the help of a UV laser, and that process is called as photopolymerization, and that process is also called as photosynthesis. And the applications will be the dental applications or the biomedical applications. In today's session, we are discussing the fuse deposition modeling or the material extrusion process. Now in this diagram you can observe like there are two types of spools you can observe. Yes, these will be work as a raw material, which will be in the form of a, we can call it as a solid. The first we can call it as support material spool, that will be used to develop the support structure. So where is the support structure? Like for example, in this diagram you can observe like there are the support structure, these will be act as a support structure to provide the support to the main built up component. After that, if suppose I want to develop a particular part or the end product or the component, yes, this will be the spool that will be used to develop those particular components, that is the built up material spool. This is your built up platform. Your built up platform is moving in up and down direction. Your extrusion or the extruder or the nozzle, which will be moving in X and Y direction. Your form of the material in this particular fuse deposition modeling is solid, and which will be in the form of, we can call it as a wire form, that is a thermoplastic material. Now you have to preheat a built up platform. Also you have to preheat, we can call it as the extruder or the nozzle. The nozzle diameter, which will be varied from, that is 0.2 to 0.8 mm. So you can provide the preheating temperature for the built up platform, that is 60 to 80. After that, the preheating temperature for we can call this for the extruder, that will be varied by application or the material by material. For example, for thermoplastic urethane, it will be maybe around 180 degrees Celsius. For TPU material, very flexible material. For example, there is a ABS material. For the ABS material, yes, that will be around maybe a 220 degrees Celsius. For PLA material, yes, which is around 200 degrees Celsius. There is one more material, that is polyvinyl alcohol. The temperature may be around 350 to 400 degrees Celsius. Just give me a minute. Yes, now, so you have preheated the extruder and built a platform. So after preheating, whenever you will start the printing, yes, but before that you should provide a CAD data in STL format, and that will be converted into a .g code, and the .g code file you are providing to the 3D printer. So after starting the printing, what will happen? The solid material which will be passing through the extruder, yes, the extrusion process, which is we can call it as a formative process or the manufacturing process, in which the shape of we can call it as a mold will be taken by a molten metal. Similarly, yes, the shape of the we can call it as a molten thermoplastic material, which will be taken by this particular very small diameter of a nozzle, that is vary from maybe a 0.2 to 0.8 mm. Yes, so whenever it is coming through this particular point, yes, the liquid will be converted into a solid with the help of a curing process. And after that, a one solid layer that will be developed onto the built up platform. After that, your built up platform is going to the downward direction by one layer thickness, and after that another layer of the we can call it as a material that will be going onto the second particular part, and this particular process which will be goes through until your product will be developed, or maybe design will be converted into your product. Now with the help of this particular we can call it as video, yes, you can observe, you can understood the fuse deposition modeling or the material extrusion. Why it is called as material extrusion? Because the material is having the extrusion process, or that will be extruded through a very smaller diameter nozzle. Extrusion process, which is a formative process or the manufacturing process that is carried out, yes, that's why it is called as material extrusion process. Yes, we are having we can call it as a one FDM 3D printer in our premises, like Acon 400 V3. Yes, the built size, that is 400 by 400 by 400 mm. The build size, like with respect to this particular size, you can develop a component or a prototype. Nozzle diameter, that is 0.2 to 0.8 or 0.4 to 0.8. Extruder, that is only single extruder that you can use it to develop the component. The printing speed, that is 200 mm per second. Now they are having like the Divide by Zero company, which is located in Mumbai. Yes, they are having a quantum 500, and the printing speed that is improved up to like the 500 mm per second. Yes, so I had the discussion with their engineers, and they have said that if suppose I want to develop maybe a 100 by 100 component, yes, maybe with the help of Acon 400 V3, it will take a time maybe a 2 hour or maybe a 4 hour. But with the help of maybe a quantum 500, yes, only it will take maybe a 0.5 hour or maybe a 30 minutes. The printing speed, that is a double, that is 500 mm per second. Yes, that is we can call it as the advanced, and they are saying that for the mass production also they are using the 3D printer. Always we are saying that to develop the customized product, always we are using the 3D printer. But nowadays, yes, the time will come for the mass production, for the batch production, the 3D printers can be used. Yes, So the customized product, like if suppose as per the customized, we can go the customer requirement, we are developing the product with the help of the 3D printers. The dimensions of the 3D printer, that is around 975 by 600 by 639 approximately, accuracy that is, or the resolution that is 80 by 80 to 250 micron. The material, that is the thermoplastic urethane, or maybe the acrylonitrile butadiene or the polylactic acid, the polycarbonate. These are the some of the materials we can use it. We can also use some of the composite material like ABS 12, or maybe the nylon 6 or nylon 13, or the 12, sorry, nylon 12. Now there may be the question like, do we have to change the extruder whenever we are changing the material? Yes, the answer will be yes. We have to change the extruder whenever you are changing the spool, because the preheating temperature for those particular materials are different. For example, for thermoplastic urethane TPU, which is very flexible material, if suppose you want to develop a spring which is having, we can call it as a flexibility, yes, you can't develop this particular application like a spring with the help of ABS or PLA. The strength will be very much good, and those are hardened material. Whenever you want a better surface finish and the strength, yes, you can go for PL and ABS. But the very flexible material, you can go with the thermoplastic urethane, which is having 180 to 200 degrees Celsius. But if you go for maybe ABS, yes, 230 to 250 degrees Celsius, those are the preheating temperature. The materials, these are the materials we can use like PLA, ABS, PETG material, nylon 6 or nylon 12, thermoplastic urethane, polycarbonate, HIPS material, or the polyvinyl alcohol. Yes, these are the some of the process we will discuss in the next session. These are the references. Thank you.